Okay, good evening, everybody, and welcome to the information session for electrical, electronic, and computer engineering. Please note that we will be launching a poll at the end of the session today. Please may I ask that you stay on, answer the questions, and don't worry, you will be answering anonymously, but we would appreciate if you could answer the short poll at the end of the session. With that, I hand you over to Professor Glen, who is the Dean and Head of School of Engineering. Prof. Bright.
Thank you very much for that introduction, and a very warm welcome to all parents, school boys and girls who are attending this open day. So just some housekeeping, if you could keep your marks, please, and you may use the chat box. The chat box at the bottom, you may use the chat box anytime to ask a question or make a comment. And who are with us today from electrical, electronic, and computer engineering will respond to your questions in the chat box. So please use the chat box at your leisure. So as mentioned, I am the Dean and Head of School, and in the School of Engineering at UKZN, University of KwaZulu-Natal, we have 4 clusters. What does a cluster mean? A cluster means a group of disciplines. What we're looking at today is electronic, electrical, and computer engineering. Yesterday, chemical engineering, and on Monday, we did the civil engineering cluster. But focusing on today, I'll be giving you a short introduction, then we'll have a number of presenters and past students also talking to you. The first thing you need to ask is, why do you want to be an engineer? Why do you want to be an engineer? Now, I can tell you now that if you like to solve problems, engineers solve problems. That's what they do, and that's what they've been doing for many, many, many years. For example, years ago, he wanted to go from one point to another, and he solved the problem by building a motor vehicle, building a train, building an aeroplane, or perhaps building a ship if it was going over water. So engineers solve problems. So if you like solving problems, then you're going to be an engineer. If you look at a country like South Africa or any other country around the world, the infrastructure of a country is built by engineers. Engineers build factories, they build roads, bridges, they build electronic components, robotics, airplanes, etc. So the infrastructure of a country is dependent on the engineers, and that's why engineers are in such demand. Anywhere in the world you go, if you have a recognized engineering degree, which I'll talk about in a minute, get yourself employed, you'll have a job, you'll be able to contribute to the country. Engineers also create wealth, and this is important because countries like to create wealth. By creating wealth, this improves the quality of life of all the citizens. So, of course, countries like the United States, Western Europe, the UK, China, and Japan, they have a lot of engineers, and they create a lot of wealth, and that's why their quality of life is often seen to be superior. Now, once you want to be an engineer, your next decision is, where do you want to do your degree? So my advice to you is, try and do your degree where the degree in engineering is accredited. Now, an accredited degree doesn't mean that the institution is accredited. An accredited degree means that there's a professional body that accredits the delivery and evaluates the degree. So, for example, if you do medicine, there's a medical professional society. If you do accounting, you'll have an accounting society. So for engineering, we have the Engineering Council of South Africa. The Engineering Council of South Africa is abbreviated ECSA, of course, after the acronym of the words, and we say it's called EXA. So the Engineering Council of South Africa accredits degrees at universities in South Africa, and all the disciplines at UKZN are accredited through the Engineering Council of South Africa, who are signatories to the Washington Accord in the United States. Now, this is the highest accreditation achievement or evaluation or body that you can achieve. And as I said, electrical, electronic, and computer are accredited and have been accredited through the Engineering Council of South Africa through the Washington Accord. The next side is, do you want to have a rewarding and stimulating and exciting career? And there's no doubt that being an engineer will provide you that. People are engineers, earn a good salary, a good wage. They're able to look after their families, extended families, and they're able to have a very good quality of life. And as I said, the main reason being because they contribute to the infrastructure and the wealth of the country, and therefore on demand. They are at the forefront of technology, research, and development. The thing you got to think about is, as being an engineer, is the curriculum that you're doing aligned with the fourth industrial revolution? So what we've done at UKZN for our curriculums through all engineering disciplines, we've reworked the curriculums, we've transformed the curriculums, and we're aligning with the cutting edge technologies associated with the fourth industrial revolution. Excuse me. So you can be sure that you're getting the most up-to-date engineering, teaching, learning, and research at UKZN, and especially in electrical, electronic, and computer engineering. So we have a very informative website, which I want you to have a look at. If you go to ukzn.ac.za, you can click on the College of Agricultural Engineering and Science, and you can go on the engineering webpage and see all the different disciplines. Now, what's important as well is that you have flagship projects. These are major projects that universities are known for. So electrical, electronic, and computer engineering have a number of flagship projects, which will be presented, so I won't let the cat out the bag now. That's important because that shows the credibility of the institution and the engineering discipline. It's also important that you have highly qualified staff that are delivering the engineering program at UKZN and in electrical, electronic, and computer engineering are highly qualified, recognized by EXA, and many of them are professional engineers. The laboratories are state-of-the-art, the facilities are excellent, and the lectures are in good condition. I encourage you to consider coming to UKZN to study engineering, electrical, electronic, and computer engineering specifically today. We are fully accredited. We have all the facilities you need, and what we need from you is we need your ambition, your enthusiasm, and we need you to be good in maths and science. I know a lot of people ask that question, what does that mean? Well, we'll be talking a little bit further later on, but you need to be good in maths and science because the degree is based on the fundamental principles of mathematics and science. So with that, I'm going to do a short, brief presentation of engineering. Thank you very much for listening, and thank you very much for joining us today. I'm now going to hand over to the electrical, electronic, computer representative, Dr. Tahmid Quazi. Thank you.
Thank you, Prof. Thank you for your remarks. Actually, you mentioned a lot of what I was going to say, so I think I don't need to say much more, but for formality's sake, I have prepared a presentation. So as Prof said, my name is Tahmid. I would, I think, begin with saying that I'm one of the past students of this place. And I've stuck around from the time I did my undergrad to my master's to my PhD to being part of the family here. There are, just for the students and parents who are here, just there are other members of staff. A lot of them are ex-students, and I think I'll keep coming back to that. So if you have any questions, please just put them on the chat. So I've got my team, the marketing team, as well as some of our managerial colleagues who are here, senior members of staff, who can answer those questions that you might have. And also at the end, we will also have a Q&A session. When you come to us at EECE, you'll realize that we are very, very, very interactive. We would like to believe we are friendly and passionate about what we do. So yeah, we would be happy to take your questions and help you explore the possibility of joining our family. So I've got 15 minutes. Thanks to Prof, I've got a few more than my 15. So you'll have to appreciate that as much as I'm going to be giving you what looks like a lecture, this session is not meant to be, as we say, it's not for information exchange as much as it is for excitement exchange. All of us who do this, especially the guys at EECE, are really, really passionate about what we do. We are excited about it, which is why, as you can see, I've stuck around from the time I came here as an undergrad student, and there are a few others here as well like that. So, yeah, so my challenge is quite big because the dean mentioned that we are 4 clusters, and our cluster or our discipline is one of the biggest because we are combining electrical, electronic, and computer engineering. So it's quite a bit of a challenge for me to, in 15 minutes, summarize everything that we do. So I'll just give you some highlights in my presentation. So hopefully you'll find it interesting. And if you have any questions, put them on the chat. I will answer them now. So I'm going to share my screen, if you allow me, and I will show the presentation. Okay, so let me try and get this onto full screen. So, so we are the discipline of electrical, electronic, and computer engineering. That's my name. And the dean mentioned it, but we really need to contextualize where we are. And I want to talk a little bit down the history line. Where we speak about where we are in terms of the 4th industrial revolution and how we got here. So the 1st industrial revolution was categorized or classified by the use of water, steam, and fire power to mechanize production. So that's what made it industrial. Then following on from that, electricity came into play. And so the water, steam, and fire was replaced with electrical power to create mass production, right? To get industry going. Then the 3rd industrial revolution is then where electronics and information came to automate production. And that's what's now led to where we are at the moment. Sorry, there we go, is the 4th industrial revolution. And if you see it from the title of the slide, I said it's the revolutions that are upon us. Because whether we like it or not, this is happening. The digital revolution is something that is going on at neck break speed. And with it, there are other revolutions that are going on because the way we do finance and economics is changing. The way assets as well as services are commoditized is changing and changing very fast. Another part of the revolution is the reality of climate change and environmental revolution because of man's negative contribution to what has happened to our planet. We have to now take stock of how we impact the environment, how we impact the world in which we live in to make it sustainable. And that we are in, as you look around us with all the havoc from a climate point of view, from a pollution point of view, this revolution is part of where we are and part of something we have to consider when we look at and talk about the 4th industrial revolution. The other one is security, because everything is so digitized, digital. If as much as we come from almost about a year ago where our physical security was in dire straits, soon, as important as that is going to be the security of what we own, because a lot of what we own are going to be digitized. So security of data, security of networks, security, because those things affect our day-to-day life. So for example, if the security of our power grid is compromised, we won't have load shedding, we will have complete blackouts. And because so much of what the industrial revolution, 4th industrial revolution, is going to digitize the systems that we use around us, security is a huge issue for us to consider. So this revolution, the 4th industrial revolution, is moving at an exponential rate in terms of its velocity, in terms of its scope, and in terms of the systems that it impacts, all across everything that we interact with in our day-to-day lives. It is disrupting every industry in every country of the world. So what the dean said about being an engineer and being in particular an electronic or electrical or computer engineer, you would be at the forefront of this fourth industrial revolution because it is a digital revolution, right? But just as a preamble, the Dean mentioned, Prof. Bright mentioned that engineers are problem solvers. We're also applied scientists, right? We're also applied mathematicians. So what our tasks in our day-to-day life is to use maths, natural sciences, engineering sciences to solve real-world problems. When I was, I think, in second or third year, one of my lecturers gave me the etymology of the word engineer, and he told me this, so I'm quoting him, that engineer comes from the French word for thinking, to solve problems using your intellectual and analytical capabilities and your knowledge of math, science, and engineering sciences. So as a summary of this part of my presentation, the choice that we have because of the waves of revolution that are upon us is whether you want to be an active, innovative producer or driver of the revolution, or do you want to be a passive, excuse my political incorrectness, dull consumer or passenger in the revolution that is upon us, right? So that is what we want to make you think about and answer this evening as you go, as we now unpack some of, well, we are discipline consisting of 3 programs. I've got 2 slides per program, and you'll have to forgive me. Maybe it's a bit dense, but I think I'm not even doing justice to the program. So I'll start with electrical engineers or electrical engineering. People who are electrical engineers are involved in the generation, conversion, storage, and transmission. Sorry, let me get that right. Generation, conversion, storage, transmission, and distribution of electricity from the source to us, the consumers. They're responsible for the development, maintenance, and utilization of the largest man-made machines in the world. As an electronic and computer engineer, I would like to dispute that because we would argue that the internet is one of the largest man-made machines in the world, but that's a debate for us to have in-house. They're both big machines, right? The one on the electrical side is the electrical power grid. And a lot of the research that's going on in the field of electrical engineering is making those grids, which have been around for over 100 years, into smart grids, thanks to the smart capabilities that come from the other disciplines of electronic and computer engineering as well. So a lot of what we present is actually, we are a team, and there's a lot of cross pollination of the technologies that are within the 3 programs. And then the other important part of it is the dealing with the environmental revolution that I mentioned. So we are driving the revolution from fossil fuels based generation, so coal, petrol, right, to renewable generation and green energy. So there we're talking about solar, we're talking about wind, and all the complexities that come around from that. So other countries are far more advanced. Places in Europe, such as Germany, have huge or much greater penetration of renewable energy. I can give you, Germany is a good example, because they really are into solar energy with a fraction of the sun that South Africa has, and yet we are behind them. So in that regard, there's a lot of work for us to do in our content. So electrical engineers are also involved in manufacturing through automation, robotics, in fields of specializations in electrical machine design, power electronics, converters, drives, also control. So you see the pictures on the bottom left there of robots controlling robots. So electrical engineers are dealing with these big scale manufacturing robots, the control algorithms, the control systems for implementing those things. I worked in the south of Durban for Toyota for a year, and I got to program these robots to do things as this image is showing. Furthermore, they're also drivers of PV, which is photovoltaic, and electric vehicle technology. So one of the biggest companies, one of the richest men in the world is our South African-born Elon Musk, and that's one of his products from his companies, which is making him so rich. That is a technology that is going to be part of the fourth industrial revolution. And further to that, another cutting-edge technology is superconductivity, which we actually have quite a strong presence in this country in terms of research and development for its application to power systems. So those are the two slides for electrical. Now moving on to electronic. This engineering field is a driving force behind the all-pervasive discipline of electronic information handling from analog to digital. So we're talking about information. So TV these days is moving from analog to digital. The sensing world is taking information from the analog to the digital world. But at its core, the electronic engineering discipline is devoted to the understanding and the application of semiconductor physics. They focus on the use, design, and application of electronic systems. So they would be developing new components, designing circuitry, and creating electronic systems for solving real-world problems such as security, surveillance, automation, etc., etc. So it's quite a vast field, and I cannot list the entire field. Just so you know, my degrees are actually in electronic engineering, even though I am housed in computer engineering. And that's because of where I then specialize with my postgraduate degrees. So the topics within electronic engineering, there's a lot of cross-pollination, as I said. And as an electronic engineer, you could be doing computer engineering and vice versa. But topics in electronic engineering include analog electronics, digital electronics, microelectronics, embedded systems. Telecommunications is a huge aspect of our program. Much of our cutting-edge research is done in telecommunications. We've got research funding from Telkom, from Siemens, Nokia, and actually our research group is this year celebrating 25 years of contributing to cutting-edge research in telecommunications. Then furthermore, electromagnetics, automation and control systems, signals and signal processing are topics under the area or under the program of electronic engineering. So just to talk a little bit on the images that you see, there one is on comms, right, and communications. There you see is the backhaul communications, the last mile communications that is making right now. I'm speaking to you from a wireless connection to an access point in my office. I could be instead in the middle of nowhere and instead connecting via the satellite network. Those who are interested, you can look it up. The Iridium satellite network covers the entire planet with network connectivity, and these are the advanced communication systems that we study in this field of electronic engineering in our discipline. Then computer engineering, which is where I call my home. And obviously you might sense a bias as I say computer engineering is at the core of the digital revolution of the fourth industrial revolution. The vision that we have, the vision of the future, is that of advanced fixed and mobile computing systems, from something that could be in the at the size of your top of your finger, all the way to massive devices and drones, driving the revolution with unprecedented processing, storage, and network capabilities. So we're thinking of billions and billions of devices and people being connected. And the idea is this machine, right? I'm arguing the machine of the Internet of Things will improve the lives of people through the use of big data, artificial intelligence, IoT. It is a thing that's been around for a long time, but it's being coined now as the Internet of Things, where anything that is on this digital part of this digital revolution will be connected to this network. On top of that, there's robotics, autonomous vehicles, virtual assistants, advanced software. So all the cool gizmo gadgets that are really going to be part of the world in the future, that's really upon us in the present. computer engineers get their hands into. So we're arguing that instead of being a passive consumer of all these high-tech products that make our life exciting, what we're saying is you can be an active innovator of the technologies that turns this vision into a reality. You can be part of it and not, you can be part of driving it as opposed to just being a passenger, as my introductory slides mentioned. It is a constantly advancing curriculum, and what we say is we are not necessarily teaching you, but we're teaching you how to learn. Right? So we are not making you learn, we're making you being experts on how to learn, because the field is changing so quickly. And so some of the areas that are involved: design and development of complex computer systems, right, from the smallest scale to the largest scale. Computer and high-speed data networks is part of computer engineering. Machine learning, deep learning, data science aspects. These are all aspects of artificial intelligence, which is a cutting-edge field that is affecting many, many parts of our life. And some of it you might know, some of it you might not know. Then real-time and parallel computing, image processing and computer vision, with all the surveillance and security that such surveillance gives you. That is all a huge part of computer engineering. Then advanced software engineering, then network security, I mentioned, that's a very important part. And then the economic and finance revolution I mentioned, where everything is going to be made into a utility given a price. And so just as we speak about the industrial revolution, right, first, second, third, and fourth, the internet that we use is going through its phases. So we've had internet 1.0, 2.0, and right now we are actually at the cusp of internet 3.0. So you might know about cryptocurrencies, which has sort of come in and out of fashion, and people find it controversial. But internet 3.0 will have at its core the technologies that developed those cryptocurrencies, not for all of that dodgy trading business, if some people find it so, but on how the internet is going to evolve into as we go into the future. So that's sort of in a summary what computer engineering is about. And just as a parting shot, because my time is up, the Dean mentioned some of these things, so I'm just going to summarize again. The EECE at UKZN is in one of the best engineering schools in the country. Our research output is one of the highest in the country. I'm talking about EEC itself. As the Dean mentioned, it is home to a large number of well-equipped laboratories and research spaces. All three of our programs are accredited by the Engineering Council of South Africa, which then makes you eligible for ICSA's highest category of professional registration, and that's internationally recognized by the Washington Accord. So that gives you the title of PREng as a professional engineer, which then makes you a global citizen. And I can, so that you will be able to practice and stretch your legs beyond these shores to places such as Canada, US, UK, Australia, New Zealand, and Europe. So you can secure top level employment both locally and internationally. And in my last slide, I just try to give you from the top of my head. This took me about 10 minutes to do. And every one of these logos that you see are companies where I know someone. I personally know someone who is an ex-UKZN student or an alumni where they call home. So as I was mentioning, quite a number of our colleagues, members of my team and in the marketing team of EECE are actually ex-UKZN students. We have students of ex-students who are also senior lecturers, senior members of staff at universities such as UCT. There's Toyota, BMW, Eskom, Telkom, Siemens, Transnet, Vodacom, MTN, Internet Solutions. A lot of our research has been in the military industrial complex. So you've got companies such as Reutech Communications. We've got students or ex-students of ours at Denel. One company at the bottom, A2D24, is actually a startup company of ex-UKZN students. Then we've got people in Ericsson. And the other thing I would like to point out is you can see that there are some non-engineering firms here. We've got students at Amazon. That's a huge company, competing with Elon for being one of the biggest companies in the world. But you see that there's companies such as ABSA and FNB and KPMG. And this points to the fact that engineers, by your qualification, you are problem solvers, right? And that problem solving does not have to be in relation to just engineering. Although a lot of the students who are in KPMG, FNB, and ABSA are solving some of their tech problems, but engineers are also found in consultancy companies because of our ability to be analytical and real world problem solvers. So this just gives you a snapshot of, to summarize where we've come from, where we are, and where the future holds. So in a nutshell, or as a parting shot, I reiterate, the wave of technological advancement is on us. And what we are arguing for is for you to consider joining our family, because that'll put you in the forefront of that wave to ride it as an innovator, as a producer, as someone who's at the cutting edge of it. So now, following on from me, so that's the end of my slides. I'd like to just hand you over to Dr. Andrew Swanson. So Andrew is a member of the Center for Power and Energy Systems, and he is also, more importantly, for tonight's discussion, he's been the manager of one of our flagship projects, not the only one, but the one that I think you guys will be most excited by because it's got robots, and we love robots. So he's been the manager of the Powerline inspection robots, which is a project that's been running in our discipline, and it's multidisciplinary, that has aspects of electrical, electronic, and computer engineering for over 10 years now. So I'll hand you over to Andrew, after which we will also have one of our ex-students. I'll introduce him once Andrew's finished, and then one of our other colleagues, Dr. Mohamed Fayaz Khan, will then sum up. So with that, I now thank you for your attention. Hopefully I haven't bored you, and I managed to share some of my excitement as to what I do. And I'll hand you over to Andrew for the video and his talk. Thank you so much.
Thanks, Tahmid. So while I bring up the video, I'm not one of the academic staff members here that went through the system. I got my degrees elsewhere, but I liked the university so much I decided to come down here. Right, I am going to open the video now, and I'm going to play it. It's a little video about the Powerline robot, and then we'll go into a little presentation about how each discipline fits into that.
Approximately 2.2 million kilometers of power lines exist around the globe, powering 195 countries. Electricity is the lifeblood of our developing world, and power lines make up the arterial network.
Traditional methods of inspection involve using helicopters or foot patrols to inspect thousands of kilometers of power line. This is very expensive, it's time consuming, and in some situations it's unsafe.
We got rust and corrosion on the coast. It's difficult to pick it up.
So effectively now there's two ways of us inspecting our lines. We either do a line patrol with staff and vehicles, and you kind of look at this line from ground level with binoculars, etc. Or there's the other option of using a helicopter line patrol.
What we've developed is a machine to take all of the hard work out of the process and the expense of it as well. So the Powerline robot is a machine that rolls along the power line and climbs past towers and other obstacles, and delivers a video feed to an operator on a ground station.
Yeah, I must say it was quite easy. It's not heavy. One guy can put it up.
The major advantage of the robot that we have is the fact that it's making contact with the line. So it's not doing things from a distance. And with that contact, as with electricity, you're able to do a lot more measurements in terms of corrosion, etc.
It also allows for remote access to far off towers. It means no climbing on the line. It means no helicopter uses. Further to that, in the future, it may be a little bit more automated, with a technician operating it as opposed to an expert or a pilot.
The views from the robot show the line and the hardware from every angle. So the operator can actually move the cameras around the line on the hardware. This gives him the opportunity to see what he would otherwise not be able to see.
Maintenance-wise, we'll pick up defects and stuff, and then you can obviously fix it quickly.
So every utility is obligated to perform inspections on their power lines to prevent these kinds of faults from occurring. Sort of world average is sitting at about 1.5 faults per 100 kilometers per year. So with better methods of inspections, they can work to bring these numbers further down. The long-term vision is to use many of these robots so that it becomes ubiquitous, so that inspections can take place in a more structured way, a lot more often. Maintenance is sometimes a preemptive activity where hardware can be replaced when it hasn't necessarily reached its end of life. So the inspection process provides a lot more data. Eventually it will be able to track the progression of faults, leading to more targeted maintenance. So you can predict the lifespan of your hardware.
The robot is definitely part of the basket of solutions in terms of the inspection of overhead transmission lines. We have other options, and from a safety perspective, it's very advantageous in areas where you don't necessarily want to risk the lives of our staff, for example. It also gives us the advantage that if a person goes out there and he does happen to be on the line, he has to carry a whole lot of very specialized equipment with him. The robot does that for you. So I think there's definite advantages there, and I think it is going to be part of the future of overhead line inspection.
Right, so that was quite cool. We've actually developed a robot that climbs along the lines, the power lines, and looks for any defects. So it means hopefully a contribution to the end of load shedding in the future. But I've got a presentation, and I'll show you a little bit about how each discipline fits into this. So we've got the disciplines of electrical, electronic, and engineering. It's electronic and computer engineering, and we'll have a look at how they each fit in. I've called this presentation Selling Robots to Japan, simply because we are currently selling our power line inspection robot to the Japanese. So imagine us guys from South Africa, KwaZulu-Natal, are selling a robot to the Japanese. That's amazing. Right, so what we saw there is that currently helicopters do inspections. You could put a person on the line. It's not really helping us much. It's not as convenient as putting a robot on the line. That robot's a little bit cheeky. It's not quite the robot we want. So we developed it rolls along the line. It communicates to our operator at ground level using some sort of connection. Right, and electrical, electronic, and computer engineering all fit into this robot. So let's break it down a little bit more. In our robot, it rolls along the lines. It needs electric machines, electric motors to actually move along the line. So that's the first thing. This is electrical engineering. We need electric machines. Next, we need some sort of power source. And we have some sort of battery management system. The more modern batteries are lithium ion or some similar polymer batteries, moving away from the lead acid, which are very heavy. So having these light batteries allows us to put them in a robot that can roll along the line without being too heavy. And this has to be controlled by a robot, which is a little bit of computer engineering. You need to program what the robot needs to do. Right, so the first little video, exactly what I've just said. We need electric machines to get the robot to roll along the line. We need electric machines to move the arms of the robot to move around the objects. And we communicate that wirelessly to our base station. Right. Let's look at our next aspect of it. What you saw was some really good images coming from the robot. So we've actually installed cameras on the robot. Those are sitting very close to the line. That allows us to inspect the power line, to inspect the equipment on the line. And it also, you'll see later, plays a little bit into the intelligence of the robot. Right, so we've got somewhat 3D cameras. They allow the robot to pick up how far away it is from objects. When we're looking at the communication, we need some specialized communication equipment to communicate those images back down to the Earth station. So, and lastly, we also have embedded computers. So you communicate with that computer from the base station, and that's how the robot knows what it's doing, knows what it's looking at, knows where to move. Right, and these are all aspects of electronic and computer engineering. And there we go. There's a nice little video. You can see these cameras really, really close up. They can get some good detail. You can see some obstacles ahead. So with a good connection, with good cameras, you know exactly what you're doing with the robot from very far away. I'll let it play a little bit more because this has got a similar video later that I want you to see. And there you can see the robot is getting quite close to that bolt. You can see a little bit of rust on that bolt. That's not what people want. If that falls off, the line could break, and that means that somebody's without power for a while. Right, so I mentioned that we have a number of items in this robot. We've got motors, we've got cameras, we've got communication modules, we've got computers, we've got lithium-ion batteries, and the problem is it's on a high voltage power line. So what do we do about that? That thing's getting zapped. It's at a high voltage, gets zapped when it gets onto the line, and that causes problems with the whole robot. So we actually had to learn to mitigate all of these issues with the high voltage and the electromagnetic interference. So here's a nice video of some of the arcing that we do. Ouch. So this robot gets whacked with all of this and it can still move. So we put a lot of work to get this right. And it's something quite unique and amazing that we managed to do this. Right, so no damage. all on the line safely. It's been whacked by high voltage. I wouldn't want to be whacked by that, so I'm glad there's a robot that can do this. Right. We spoke a lot about the fourth industrial revolution and maybe some computer intelligence. I'm more referring to the artificial intelligence here. So what we want in the future is we want a little robot in there. We want him to control what's going on, but we've actually got to teach him what to do. And that takes a lot of time and effort and algorithms and learning and teaching the robot. So we know we've got a camera. We want that camera to recognize objects. We want him to recognize a power line. We want him to recognize any obstacle on the line. We want that robot to know when to control the motor, what movements would get it around that obstacle. We also want that artificial intelligence to communicate the right sort of stuff back to the ground station. So let's look here. I showed you this one earlier. This is part of the image recognition. What you can see in the red there is we've trained our computer to recognize the power line. And you can see in the blue, that's a different obstacle. It recognizes that obstacle. So if we can recognize it, we can teach the robot to then climb around it. And that's the video that we saw earlier of it climbing around. Very cool. Right, so what I said was, if we can recognize objects, we can teach the robot to move around it. So this is a movement where we've taught the robot to move around this particular obstacle. And you can see the path it's taking to make sure it can get on and off the line. Very cool program. A computer engineer would have made this. And of course, you all believe me, so let's show you it's in action. There's no human controlling this robot here. We've predefined the path that it's taking. Very cool. Did that all by itself. Right, so that's a little bit about one of the projects that we've done. We've got plenty more projects, and we encourage you to be an electronic or computer engineer. We love working together because we're a good discipline, and we've got all the skills to take us forward in the future. Right, thank you.
Thank you, Andrew. So with that, I'd like to now introduce you to one of our ex-students. He's now an engineer working in industry in his own right. So I am ashamed to call him my student, but he is my ex-student. We are still collaborators. We are collaborators now. So this is Andre. He did his undergrad, one of the top students in computer engineering. Then he did his master's with us. And also achieved that quite successfully. At the moment, I think he got a job, Andre, correct me, in one day. So he's out in industry, successfully living his life. So I think it's a good thing that you get an opportunity to hear from a student and not from us old fogies who've been here forever and don't want to leave. So Andre, please, if you just share some thoughts on your journey and your future as well. Thank you. Andre, no, we can't hear you.
My apologies.
Yeah,
New headset.
That's better.
Hi, everyone. Yeah, Thank you, Dr. Quazi, for that introduction. Before I carry on, I'd like to greet all of my previous lecturers. I see there's a lot of them present here. So I'm here to try and give all of you some more insight as to what it is to be a student at the university. I started in 2016, did my undergrad, and then I did my master's, which I completed last year. And yes, Dr. Quazi, you're correct. I did get a job. I got a job the same day that I got my statement of degree completion for my master's. That was a very pleasant experience. But yeah, let me start with the harsh realities. So shall we say, the degrees, they're very fulfilling, but they're very hard work. There's a lot of information that you will gather when you study at the university, and a lot of it requires a lot of hard work to digest properly. But none of it is ever boring. You won't ever find yourself in a situation where you're looking at work that you say, oh, I already know this, or this isn't something I want to know. All of the work, you can see how it fits together in the grand scheme of things. With that being said, a lot of the EECE, electrical and computer engineering, will share a lot of the same modules, but the differences, especially when it comes to your third and fourth year, will be what distinguish you. So I studied computer engineering, and I chose it simply because I love computers, but I went through my journey with all of the other disciplines. We shared a lot of work. We not that we cheated. We shared a lot of passions for the work. We collaborated on a lot of projects, whether by choice or as that was part of the module. And you'll meet a lot of good people along the way, people that will share your passion for the work that you want to do. In my fourth year, I had the privilege of being able to choose my final project, and I decided to take a project that incorporated as many of the different topics that I had learned through my 4 years at the undergraduate level. I built a robotic arm to assist disabled individuals, and that incorporated, of course, the computer side of it, but it also brought in some mechatronic engineering and electrical engineering, and it was a very good way for me to actually see how everything meshes together. Then after I had completed my undergraduate degree, I went into my master's with Dr. Quazi being my supervisor. For my master's, I focused very much on the security space. Going back to what Dr. Quazi said in his presentation, there's a lot of focus around the world at the moment, and very much so in South Africa as well, on securing the devices that we use every day. Dr. Quazi also mentioned IoT. IoT's definition is broadening very, very rapidly. A couple of years ago, we would have considered IoT to be a smart fridge, but now IoT is becoming everything. And the interactions we have with those devices are very important for where we're moving as a human race. And my master's focused on securing those IoT devices against attacks, against cybersecurity attacks. I did my master's through research. So that means that in doing that, I tried to be at the forefront of what's current in the field of IoT security. I'm in the process currently, as Dr. Quazi said, we're collaborators. I'm in the process currently of publishing some of the work that I did during my master's. And yeah, that is, I think, the biggest takeaway from my degree is that you don't get left behind. You are put in the position that you can push the field, and by doing that, the world forward. You're not simply a follower. I saw a question about the difference between computer engineering and computer science earlier. And what Dr. Naidu said was very true. We computer engineers, we build the computers, we write the new programming languages. We're the ones that push that field forward. And the same goes for the other disciplines. They, in their own right, push their fields forward and take the rest of everyone with them. I then was lucky enough to have a choice of job opportunities laid out before me because of my degree. I turned down quite a few, notably ABSA and Amazon. And I decided to go work for a company called Insight Consulting. The company that I'm working at now, I'm a junior full stack developer there at the moment. We do internal web-based tools for some of the largest companies in South Africa. At the moment, our flagship client is a company called Engage. Now, I know a lot of you may not have heard of them, but they're the parent company for Spa. So every time you walk into a Spa and you go buy a pie from the heater, that gets logged through a system that we've built for them. And we do the same thing for RCL Foods, which is in charge of Checkers. We are busy taking on a new client for a very fast expanding fast food chain, which I don't think I'm allowed to mention yet. But I'll say when it comes to working, your degree will stand you in very good stead. The degree, as many of the other speakers have said tonight, it's accredited by EXA, the Engineering Council of South Africa, and EXA is signed to what we call the Washington Accords. These Washington Accords assure you that the degree that you get at UKZN is recognized internationally. And by it being recognized internationally, it has a lot more recognition locally as well. So your degree speaks volumes, not just to the time you've spent at university, but to your problem solving ability and to the standard of your education. So yeah, when it gets to the numbers at the end of the day, it's a good degree. It's hard work, but it's a good degree. It's a good learning experience. The biggest takeaway, I'll leave you, the biggest takeaway that I took from university was, firstly, when you get through the degree, you will have garnered a skill for picking up new information much faster than the average individual. Your ability to process new information and apply that information in the correct way is highly tuned. And the more personal aspect to my time at the university was the bonds I formed not just with my fellow students, but with my lecturers as well. You go through a lot of trials and tribulations, and through those, a lot of friendships will be formed. I'm still very, very close with my group of friends from university, even though they didn't do masters with me. We still are in contact almost every single day. We still get together frequently, and a lot of that is based on that foundation of what we did at university and the experiences we had there. I still regularly speak with Dr. Quazi, both for work, but also on a personal level. You'll find when you join the university, there's a lot of good people. Yeah, I think that about sums up my experience. It's hard work, but there's a lot of positives to it.
Thank you so much, Andre, for being informative and being heartful. We really, really appreciate that. And I hope that the potential Andres take inspiration from that and then join our family. The analogy I like to use is in echoing what Andre says about the difficulty, the challenges, is something I often teach my students, that when you are climbing a mountain or a hill, say the Drakensberg, yes, it is hard work. Your legs pain, but when you get to the top and look back at your achievement, it just makes it all that worth it. So with that, I just want to hand over to sort of summarize. Actually, Fayaz has got more than a few minutes to summarize. He's been given 10 at least. So I'd like Fayaz to use that. And echoing what Andre said, Fayaz and I, we were doing our masters together. So what Andre said in forming friendships and relationships and brotherhood, ours is an example of that. So just a little bit of introduction to Dr. Mohamed Fayaz Khan. So he finished his master's and then went to work for Eskom or Ishcom, whichever you prefer. He worked there for 20 years. And in that time, his achievements are far more than being an engineer at Eskom. He got his professional registration done. He got his PhD done, as well as being appointed as a fellow of the South African Institute of Electrical Engineers. So obviously, he's either a very good multitasker or he was more dedicated to other avenues than Eskom itself. But I'll let Fayaz take that over, tell you more about it, and also to conclude on our behalf. Thank you, Fayaz.
Thank you, Dr. Quazi. I just want to clarify, though, your earlier statement about us being old fogies. I don't agree with that. I think you're on your own there. Maybe more gray, but I don't classify myself that way. Good evening to all of you. The students that are here, our potential students, the parents who may be joining in as well, and my fellow colleagues. It's always a very challenging thing to have to go last in a presentation like this, because all the cool lines are taken and you kind of sound like you're repeating what other people have said, so it's a bit unoriginal, but I think I'll be able to do a good job of it, hopefully. And I don't want to take up too much more of your time, so hopefully we can get to the Q&A session, which is going to be a lot more informal. I decided not to have a background and to talk from my office because I think that's more personal, and without a presentation, we'll be able to actually kind of almost have a conversation. These conversations are best had in person, but I think let's make the best of it. I think Dr. Quazi felt confident asking me to close because hopefully the energy that I'm going to exude is palpable from the point of view that I really love this discipline. You know, he mentioned that we kind of did our masters together all the way back in 2000, 2002. And thereafter, I kind of left but never left. And now I've come back after 20 years to take up a position as a senior lecturer in the Department of Electrical Engineering. And people may wonder, why would I do that, right? Did I have some sort of obsession with wanting to know what it's like to live with a lower salary? Was it all the Eskom jokes? I think it was the latter. I don't know whether I could handle any more of that, but in all seriousness, the reason I personally came back, my personal story for coming back to the university was during lockdown, I started reading a lot more, and I read this truly horrific book called The Uninhabitable Earth. The context of that book is it's a book on climate change and what we can expect to happen in 2050, in 2100 if things don't change. So I say 2100, sorry. So in any case, that book depressed me first, it scared me. But after going through all of those kind of processes, I then felt I can't just kind of, you know, give into this, right? It's our kids are going to inherit this planet, and what planet is there? You know, we need to kind of work on this. And then I also kind of humbly came to the realization that I didn't have the skill set to kind of take this challenge on by myself. I don't think any one person does. I felt that perhaps my expertise would best be placed helping equip the engineers of tomorrow to kind of face these upcoming problems that are going to come, because they are the ones who kind of have to fix this mess we may have created for them. So I think in terms of my story, you can be rest assured that I'm not telling you to come to a place that I myself did not choose to go to. It's a place that's really kind of full of good vibes. You saw it in Andrew's video, and as he's saying, it's one of the pilot projects that we're talking about. It's a project that kind of we had to debate as to which one to put in. We put that one in particularly because it incorporates a lot of all three of our different engineering programs that we offer. So be rest assured that there's lots of very good work going on there. The discipline of electrical, electronic, and computer engineering, it's a great place to study. It has a perfect blend of young and old, theoretical and practical, and also cool and strict lecturers. Obviously, we put all the cool lecturers here today. So, you'll meet the stricter ones when you come for your first day of registration. The campus is historic and massive, and the labs are one of a kind. And we now offer complimentary courses also on entrepreneurship, engineering, business, and environmental science. So when we became signatories to the Washington Accord, I was still in university around then. I guess I'm dating myself now. But I remember one of the ways they made us join up is if we kind of, I don't want to say dumbed down our degree, because that doesn't go down well with our colleagues from the business science, etc. But they needed us to make it more varied. And I think it was a good thing. I think we needed to kind of have a wider range in terms of not just focusing only on the maths and science, but also on the bigger aspects of life and how we kind of fit in together. This next decade is going to be dominated by what us as electrical engineers call the 3Ds. Digitization, and people spoke about that, the fourth industrial revolution, Internet of Things, decentralization, and that's more in specific regard to the power system in terms of where we have this one-way flow of power in the past. Now things are going to be flowing in multiple directions. And disruption. I think that's the one thing that we can all be guaranteed of, is that things are going to change. And I really enjoyed Andre's talk. I haven't had a chance to meet him personally, but what he said kind of stands out, is that you're now kind of equipped, or you will be equipped if you do a degree at an engineering degree, you will be equipped to kind of think out of the box, think on your feet, because the one thing you can always be guaranteed of is change. I know us in KZN, we've had a lot of change over the last 3 years. We had to cope with lockdown, we had to cope with social violence, we had to cope with the floods. And our response to a lot of those things, I mean, try and imagine what we would have done in lockdown without the tools of EECE, without the kind of ability to have Teams meeting, without the ability to have a power system that still was going to run, without the ability of having our smartphones and our iPads to help our kids do their schoolwork. Everything there kind of majorly revolved around these kind of this discipline. And therefore it's very important. Also kind of going forward, if you think of all the upcoming challenges, I may have seen it in other presentations, the fourth industrial revolution, people were talking about electric vehicles in the chat. We're talking about renewable energy. We're talking about 3D printing and all the things that can kind of bring to you, space travel, all of those things. A degree in any one of these three disciplines, electrical, electronic, or computer, that's kind of where you need to be if you want to get a job. And that job market is set to explode. So if you're kind of sitting back and thinking, I want a career where it's going to be easier for me to get a job, I don't think you can look much further. Because even anything else that kind of has to do with it involves us in terms of a collaborative effort. You want to send a rocket up to the moon, we kind of do the control systems that handle all of those things, right? Talking about electric cars, etc. Yes, it's mechanically constructed, but the batteries are us, the control systems are us, the sensors are all us. So it's something that you definitely want to think about, right? Joining our discipline also kind of allows you a bit of flexibility. I know we had a few discussions of that in the chat regarding whether you can move from computer to electronic, etc. Within reason, you can. It's a bit more easier within these three than it would be to move from electrical to, say, civil. So as you're going along in the first year or so, you feel as though maybe your passion lies elsewhere. It's a lot easier to kind of make that move between kind of electrical or electronic, or computer and electrical, etc. So I think in closing, I think I trust that my colleagues and I have done an adequate job of kind of piquing your interest in what you can achieve by getting a degree here. I lecture first year students in their electrical design course. A lot of the first year students don't see the lecturers at EECE because you kind of get your grounding in first year in physics and chemistry and maths and applied maths. But having seen these first year children, it's really cool because I can see they kind of all have the same passion. They all doe-eyed, full of energy, wanting to come out and change the world. And if that's you, I think EECE at UKZN is the place that you want to be. So I think with that, I can conclude my bit of the talk. Just to remind you what Swasti said at the beginning, don't forget that there's a poll. And if you can, please maybe take your time to fill that out before you leave. But I think now we will start the Q&A, Tahmid. So over to you.
Yeah, so if there are anyone to take questions, just the first one that I sort of picked up on the chat where people were talking about interchanging. I'll speak from personal experience. I joined one discipline, and after first year, I changed my mind. So I joined electronic engineering, and the rest is history. So it's still possible, but the fact that you guys are here and interested and already doing your research shows that you are way ahead of me in deciding where you really want to be. So even though you might have applied or have thought of one, really explore. It's good that we're having these sessions, and I know Swasti said that this will not be the only one. We will try and have more sessions like this so that you can interact with us and we can inform you, or answer any questions that you might have. That it's still flexible, that you can chart your own way as your interests take you from one stage to the next. So with that, I'll just leave it open for questions. You can still put them on the chat, but if you'd like to ask any questions by speaking, just maybe raise your hand, and then I will try and coordinate it. And yeah, so we do have some time left because the session officially goes on till 7. But I think this is where we would like to just, those who want to leave, I know it's been a long session, you're more than welcome to, and those who want to stay, we'll hang around. We're happy to talk to you and answer any questions. Another point before people do leave is that in terms of the application itself, we'd like to point out that you can apply early and get early acceptance. So if your marks are good and within well, you've consistently performed well in your standard 9, maybe your first term of matric and mid-year, you can apply via the CAO, I think, Central Applications Office. But you can also contact us. You can contact us via the website. Any one of us will tell you what to do, but you need to inform us that you've applied early so that we can track the application from our side, even though it's going via the CAO, and we will do whatever we can to help you. If you are really keen on joining us and you want to get in early and not wait for the rush at the end, please go ahead and apply early, or apply for early acceptance through the CAO and inform us. Reach out to us. And if we can help you in any way, we'll gladly do so. So I think that's sort of a final point to those who have a settled mind that they want to join this family and on the way to how to do that. Okay, so I'm gonna kill my video, but I'll stay online and take any questions if there are. I see. Okay, so where can I work as a qualified electrical engineer? So Eskom is a good example, but there are other companies in industry where electrical engineers, I mean, and in my slides at the end, I mentioned Sasol, for example. Right, so Liam, so does computer engineering
Tahmid, do you want me to maybe just take that a bit more?
Yeah, please go ahead. Yes.
Okay, yeah, just from an electrical engineering point of view, obviously you have the utilities, you know, in terms of Eskom and the Equatorial electricity and city power, etc. But remember, all of those are kind of maintained and supported by these manufacturers that are international and local as well. So those are the other aspects. But going forward, a lot of my colleagues in electrical engineering are moving to the kind of the more popular kind of choices now in terms of renewable energy. So there's kind of consulting that gets done in terms of those IPPs, SSEG, which stands for small scale embedded generation. So there's a lots of different avenues for electrical engineers, other than just ESCOM, but obviously ESCOM employs a lot of electrical engineers. Thanks, Tahmid.
Yeah, thanks, Fayaz. So the next one that I see is computer science. I think this came up earlier as well. Computer science is related to computer engineering. Yes and no. Well, they both have the word computer in it. But computer science is a 3-year degree. Computer engineering is a 4-year degree. In terms of engineers, in my slide, we said we are applied scientists. So there are let me put it this way. There are many of the functions that a computer scientist can do and computer engineering can do with a bit of training. On the flip side, there are certain jobs that only a computer engineer can do that a computer scientist cannot do. Okay, so in terms of pay grade or in terms of responsibility, the engineer will always have an edge over the computer scientist. But look, when it gets to the work industry, the work environment, a lot of those rules are. It's not about necessarily the art, but the artist. So if you're really good at what you do, you could be functional and better than others, no matter what their degree is. Right. So another one, so does computer engineering just to the systems behind these huge companies. Right. Before I take that, Andrew, yeah, you want to?
Yeah, just to add to that, computer science versus computer engineering, the computer engineering is a professional degree. So if you go a route where you want to be professionally registered, computer scientists can't do that. On top of that, your degree would be better internationally recognized because you could be a professional engineer in the countries that are part of the Washington Accord. So if you're in the UK and you go the route of being a professional engineer, they call it chartered engineer there, it's recognized there as well. That's it.
Thank you, Andrew. Another one that I'm seeing, I'm just sort of selecting in no particular order. Yeah, so if you get accepted, can we get assistance on course selections from you guys? Look, when you begin your degree, your courses are pretty much set for you. But you have to choose either electrical, electronic, or computer. And when you get to first year, you really get to know the topics. But in your latter years, where you do get to choose, then yes, we will help you and guide you along on that process. Okay. Let me see if there's any other interesting questions. So Liashin, you asked, will you be able to apply for provisional acceptance at the end of this year? Well, the earlier you apply, the quicker you get that early acceptance, the better for you. So, and then we would want you to apply with your marks in Standard 9. So if you've been a consistently high performer, right, and end of Standard 9, first term, mid-year and trials, yes, we would want you to apply and get in. So why wait till the end of the year? You can get in right now. Okay. Right. Liam, I think, yeah, you're really trying to figure out between computer science and computer engineering. So does computer science is more involved in the IT sector? Well, it depends on what you define as the IT sector. Yes, there are certain jobs in the IT sector that is just pure programming, and the computer scientists are the geeks who are designed for that. Engineers really like to do engineering, and not as much as we can do programming computers or programming systems. Developing software is part of our thing, but our degree is much more than that. And the other aspect that is, I think Andre alluded to, or was it Fayaz, that part of our degree is to be entrepreneurial. I mentioned that one of the startup companies on my list was started up by ex-students of ours. The engineering guys are far more equipped to do that than the computer scientists. Right. How many undergrad students does UKZN take? A lot. All right. So at the point why we are on this drive is we are not actually getting as many students as we want. So yes, I think that's not something you should worry about. Just go ahead, put your applications in. If you're good and deserving, you will find a place, God willing, into our programs. Right. Okay, electrical engineers work mainly with power, or do they do some other work? Well, I think we've covered some of that. So it's not just about power. There's also control systems, there's robotics and automation, manufacturing as well. Right. So last question is, where can I submit our results if I'm in grade 11? So if you're in grade 11, I would think wait till your grade 11 is finished. So then you can apply to, so if you're in grade 11 now, you'd be applying next year for the year after. So when the applications open, in your case, it would be for 2024, wait for that. And then as soon as it's open with your grade 11 marks and maybe your first term marks, you should go and apply for early acceptance. Right, then is physics in the first year related to high school, or would it be more like applied physics? Interesting question. I think if I jog my memory, what we study in physics and maths in high school gets covered probably within the first 3 weeks of first year in engineering. So it does become useful, but then really it takes off from there. So yeah, it's useful that you bring that knowledge across. And we definitely build on it and take it to much higher levels throughout your first, second, third, and fourth years. All right, so I think that's everything on the chat. Any other questions from hands up? I don't see any. So I think we've covered hopefully everyone's questions. So with that, I'm just going to hand you over back to Swasti, who is the coordinator of these sessions. Again, on behalf of the discipline and our team, would like to thank you for joining us this evening and wish you the best of luck. And yeah, you can find us through our website. If you have further questions, you can reach out to us and we will do our best to try and guide you and help you. And we hope that our session has been interesting and that you do consider joining us, if not us, in other disciplines within the university. UKZN has a very strong engineering school, and yeah, we really do wish that you join us and be part of our family. So with that, I hand you over back to Swasti with a final thanks.
Thank you for that, Tahmid, and thank you everybody for joining us. We hope you join us for the last session tomorrow, which is with mechanical engineering. And with that, I would like to wish you all a pleasant evening. Thank you. Bye-bye.